Hi there, and welcome to today's video where we are going to be looking at angles within shapes, or what we would like to call interior or exterior angles. And you can see here that I've got three different shapes drawn, and I've got a bunch of different angles and some with none at all. And what we're going to be doing today is we're going to be looking at how is it that we solve missing angles using either the angles that we have or the angles that are maybe to the outside of the shape in order for us to determine what missing angles might be. So let's get started with this guy first. Here we have a triangle. And you can see here that we've got two angles that are the same. They're both 65 degrees. And what we don't have is this guy. This is our missing angle. We don't know what it is. Now you may or may not recall the interior angle of triangles is going to always be 180 degrees. So a triangle is going to be 180 degrees. Now, I want to talk to you a little bit about that, why that is first. And I need to take you all the way back to circles. So in previous lessons, we talked about the area of a circle and how if you cut up pieces of a circle to infinitesimally small pieces, you can actually get a circle to actually turn into a rectangle like we have here. And we know that a circle has 360 degrees around. So essentially, if we're following that logic there, if we've got a circle at 360 degrees, and we cut it up into very, very, very small pieces, and we form a rectangle out of it as well, then we can come to the conclusion that a rectangle also has 360 degrees inside of it. And I've drawn a rectangle here because this rectangle, if we think about it in terms of, let's look at the angles, what we have here is we've got four groups of 90 degrees. This is a 90-degree angle right here, 90 degrees. This right here is a 90-degree angle, this right here is a 90-degree angle, and this right here is a 90-degree angle as well. And so essentially if we just do the math, we've got 90 and 90, which is 180, 90 and 90, which is 180 as well, or all together, four groups of 90 is 360 degrees. So if we come back to that whole idea about the triangle, and why does the triangle have 180 degrees? Well, it's simply because if we take and cut this rectangle in half, we are taking 360 degrees and cutting it in half in order to create a triangle. So this is the conceptual understanding of why a triangle would have 180 degrees inside of it. And now that we know that, we know what the total interior angles are going to equal, we can solve what this missing angle would be if we had two measurements. And we would do that by this. We would take these two angles and add them together. So we have 65 and 65. That's going to give us 130. We know that it's supposed to be 180. So why don't we just subtract them? 180 from 130, or 130 from 180, 180 minus 130. And that's going to give us 50 degrees. And therefore, this angle can only be one thing. It can only be 50 degrees because if we take 65 and 65 and add it together, the missing angle to get 180 again would be 50. So what happens, however, when we have something like this? If you take a look here, this is going to require a little bit more knowledge, but what we've got here is we've got an angle that's happening outside of our triangle. So let me circle that here. This is what we call an exterior angle because it's outside the shape. But fear not, just because the angle is outside the shape doesn't necessarily mean that we can't use it. Because if you're thinking about angles here, and this is going to recall a little bit of knowledge about what you know about angles, we know like acute angles, we know obtuse angles, we know right angles. Well, that's not hardly a right angle. We know right angles as best as I can, like that. And then we know this angle as well, a straight line, which we would call a straight angle. This is 180 degrees. Kind of interesting, it's convenience, back to 180. Which means that if we were traveling this way, let's go this way, if we were traveled in that group, we would be 180 degrees. So if we're going across the top, switch up the colors here. If we're going across the top, this 180 is split right there by 110, which means that the remainder would be 180 less 110, or 70 degrees on the inside. Let me explain that again. This is a straight line traveling in this triangle. And if we have 110 degrees of that straight line, then what's missing would be our interior angle, or what we would have to come across would be the remainder of that 180. And now that we have this, we would simply just need to do the math without having to use a protractor. We've got 70 and 60, which again is going to be 130. If we take that angle and add them together, and our missing angle has to be the remainder of 180 from 130, which is going to give us, 130 from 180, which is going to be, once again, 50 degrees. So let's recap, because we just did a lot really quickly. So let's go through this again. Interior angles are going to be determined by adding the angles and then finding the missing one, but you would need to know how much the total interior angles are going to add up to. That's one thing that we didn't talk about. Anytime you add a line to a shape, you're adding 180 degrees. So in this case, let's just go through this real quick. In this case, if this is 180, there's 3 lines at 180. Here's 4 lines at 360. 180 plus 180 is 360. If we have a 5th line, if we create a hexagon, we're adding 1 additional line, 5 lines, but we're going to add 180 to it, which would give us 540. And then so on and so forth. If we add a 6th line to it, we add another 180, which is going to give us, 720. And that's what you would need to remember. There's a formula behind it. You would take, I think it's n minus 2 times 180 or something like that. N minus 2 times 180 degrees would give you what you're looking at. So if you had n is the length of the shapes, that's what we would have. So in this case, if we had 4 lines minus 2 times 180, 4 minus 2 would give us, this would be in a bracket, 4 minus 2 would give us 2, times 180 would give us 360. That's how it would work. If we have 3 lines minus 2 would give us 1 line times 180 would give us 180 degrees. So that's the formula that we would need to use in order to solve this. So again, recap, 180 degrees for a triangle. Triangles will make up many of these regular polygons that we're going to be looking at. As you're adding a line, you're adding 180 degrees. And as you're looking at interior angles, as long as you can remember that the interior angles are supposed to add up to something, you should be able to find missing angles using lines that you know, both on the inside and the outside. That was a very fast video on interior and exterior angles. What I would ask you to do, please go back and rewatch the video as needed, pause if you need to, and if there's something that doesn't make sense, drop a comment down below and I will respond as best I can. And we'll catch you guys all in the next video. Thank you for watching.